Why does the program on the bottom screen run so much faster than the top? Stay tuned to find out. In this video, we're going to look at the speed differences between a program written in BASIC versus a program written in assembly language. What is BASIC? BASIC stands for Beginner's All-Purpose Symbolic Instruction Code. It's a simple language that's fairly easy to use, but is an interpreted language, meaning it doesn't run natively on the processor on the computer. And there's another program that interprets the instructions and translates those into instructions that run on the processor. Assembly language, on the other hand, is a low-level code that the processor actually runs. That's why assembly runs much faster because there is no interpreter needed. On the screen here is a small basic program I've written that writes a block to the screen and then moves it across the screen character by character and row by row. Here you can see the block clearly moving across the screen, and this is as fast as this program can run. It's going to go all the way across the screen, the 64 characters across by the 16 lines down, and then it simply ends when it's done. You can see it's not particularly fast, and this is the fastest I could make it work. It starts off by setting S to the beginning of the memory location of the screen mapped memory, which is in the upper left, and then sets T to one character ahead of that, or one memory location ahead of that. It writes into the S the value of 255, which is that block character, and then it increments from 0 to 1022, and basically writes into the T value, which is the next character ahead, the value that was in the previous memory location, which was the one character behind. And then it erases the previous character by putting a 32 in there, which is basically a blank space. It increments both of those pointers and then repeats in the loop, and then it finally ends. Okay, now I've got on the screen an assembly language program that basically does the same thing. If we walk through this program quickly, org basically says this is the memory location where we're going to start this program being loaded into. Start tells it to set the register pair HL7 with the value 15360, memory location of the screen, and load into the register pair DE 15361, which is the next character over in the screen map memory. BC contains the value 1022, and here's where we start actually writing to the screen. I say write to what HL7 points to, which is that 15360 memory location, the value 255, which is the block. And then starting here with this loop, I'll load from that same location into this register A. So A will have 255, and then I'm going to load into the DE, what DE is pointing to, 15361, the value A. And then I'm going to erase it by writing into what I just read from the value 32, which is a space or a blank. I increment both of those pointers, and then I've got this little extra code here that you didn't see in the basic program, which is where I set the value A to 128. I decrement it, and then I jump non-zero and loop here over and over and over, basically 128 times. If I don't have this here, the program basically runs instantly and you really don't see anything on the screen. So I did this just so it would be fast enough you could see it, but not too fast that you don't see anything. Once it gets done basically wasting time here, I decrement BC, which had this value 1022. And in order to check whether BC is 0, there's no assembly language instruction that I found that would do that. I load into A the value B, and then I OR it with C, which basically means if any of the bits are set, A will have that bit set. And if that value is non-zero, I go back to loop. So basically, if B or C is non-zero, it's going to go back to the loop. When B and C are both 0, it'll go to the next instruction here, which is JP410 hex, which is the location that the TRS DOS will start up again and the program basically exits. And then I have the last instruction here, end, with the label start, which basically tells it that that's where we want the program to begin executing when I load it. So I've assembled this as demo 4, and it wrote it to disk. And then I'm going to quit, out of the editor assembler, and then I'm going to run demo 4, and we'll see how quickly it runs. And you can see that was pretty fast. That was way faster than the basic program ran. We'll run it again here. And just for fun, I created a demo 4A where basically I remove that loop and it doesn't really show much. It basically just runs instantly and the cursor is down here at the end. So you don't see much. So assembly language is much, much faster than basic. So some of the benefits of programming in assembly language are programs will run much faster and programs generally may take less memory. In our example, our basic program takes 124 bytes versus our assembly language program once compiled takes 35 bytes. And when you're dealing with a machine that has maybe 16K of memory, every byte counts. Okay, so some of the disadvantages of programming in assembly language are it's more difficult to program in, as you can kind of see. You do need a compiler, and you need to compile each time you want it to run, and it's not forgiving of errors. If you make a mistake, the machine can crash, reboot, and other issues can occur. And for those interested, I'm going to include here at the end some information on the Z80 CPU register configuration. The main registry set, A and F, B, C, D, E, and HL, they're all each letter individually 8-bit registers, but they can be used as pairs, B, C, D, E, and HL. The 8-bit registers can have values between 0 and 255, and the pair type, BCDEHL, are 16-bit registers that can have values between 0 and 65535. The video display on the TRS-80 Model 1 consists of 64 characters horizontally by 16 characters vertically. That adds up to 1K of memory. The screen is mapped to memory starting at 3C00 hex or 15360. You've seen that number in my programs. And then goes 1K later to 3FFF or 16383. Well, thanks for watching. Please like and subscribe, and take a look at one of my other videos here.